Have you ever watched a pot of water boil? It might seem like a simple everyday event, but if you really pay attention, there's something almost mesmerizing about it. It's something we see all the time, in kitchens all over the world, but we rarely stop to think about what's actually happening right before our eyes. You turn on the heat, and at first the water looks completely still, calm, almost lifeless. Nothing seems to change for a while. But then, if you look closely, tiny bubbles start to form at the very bottom of the pot, clinging to the surface like little pearls of air. Soon those bubbles multiply and grow, and before you know it, the whole pot is alive with movement, bubbling and churning in a transformation we often take for granted. Boiling water isn't just for cooking pasta or making tea. It's a force of nature that powers mighty steam engines, creates spectacular geysers in the wild, and even fogs up your bathroom mirror after a hot shower. But have you ever wondered what's really happening in that pot? What's the secret behind those dancing bubbles? Why does water suddenly start to dance and bubble so energetically at a certain temperature, and not before? For water, that magic number is 100 degrees Celsius or 212 degrees Fahrenheit. It's a universal constant, no matter where you are. But what's so special about that temperature? Why is it the tipping point where everything changes? Why does water boil then and not a moment sooner? What's stopping it from bubbling at 90 or even 99 degrees? The answer lies in the invisible world inside every drop of water, a world where molecules are constantly moving, colliding, and breaking free. Let's dive in together and uncover the fascinating science behind this everyday magic and see how something so ordinary is actually extraordinary. It's an epic journey from calm, quiet liquid to a bubbling, energetic gas right in your own kitchen. To truly understand what happens when water boils, let's zoom in, way in, into the hidden world of water molecules. A place we can't see with our eyes alone. Imagine you have a pair of super-powered goggles that let you peer into this invisible universe, revealing zillions of tiny, wiggling water molecules, each one constantly on the move. Even in a glass of cold water, these molecules never sit still. They're always jiggling, vibrating, and bumping into each other, held together by a special attraction called hydrogen bonding. This invisible force keeps water in its liquid form, allowing the molecules to slide and flow past one another, but not drift apart completely like in a gas. When you heat the water, you're actually giving extra energy to these molecules, like fueling up tiny engines inside each one. It's just like turning up the music at a party. The molecules start to dance faster and faster, bumping into each other with more excitement and energy. As they get more energetic, their group hug weakens. The bonds that once held them close start to loosen, and the molecules push harder against each other, eager to break free. The more heat you add, the wilder and more chaotic their dance becomes, until the water is alive with motion. Eventually, some molecules get so much energy that they can escape the liquid entirely, breaking away to become something new, water vapor or steam. This is the secret first step to the bubbling magic we see when water boils. The moment when molecules break free and rise up as bubbles. The party is just getting started. The more energy you add, the more molecules join in, turning the whole pot into a lively, bubbling celebration. So let's keep watching and see what happens next in this fascinating world of wiggling water molecules. As you keep adding heat, the molecules at the bottom of the pot get the most energy. They start moving so fast that some break free from the liquid entirely, turning into water vapor, steam. At first, these gas molecules form tiny, invisible pockets at the bottom. The cooler, heavier water above often crushes these first bubbles before they can rise. That faint hissing sound is the sound of steam pockets forming and collapsing. As more heat is added, more molecules escape and the steam bubbles grow. They fight against the pressure of the water above, trying to survive and rise. The temperature climbs closer to that magic boiling point. The battle between steam and liquid is heating up. Soon, everything changes. At 100 degrees Celsius, something remarkable happens. The pressure inside the tiny steam bubbles at the bottom of the pot finally matches the weight of the water above them. This balance is crucial. It's what allows the bubbles to survive and grow instead of collapsing under the pressure. The bubbles begin to rise, growing larger as they move upward through the hot water. This is the process we call boiling. A dramatic transformation happening right before our eyes. Those rolling, tumbling bubbles aren't just air trapped in water, they're actually pockets of water vapor. Because vapor is lighter than liquid, these bubbles float upward, carrying energy with them. When the bubbles reach the surface, they burst open, releasing invisible steam into the air. This is water escaping as a gas right in your kitchen. If you keep the heat on, more and more water molecules gain enough energy to break free, turning into steam and escaping until, eventually, the pot is empty. This is a classic example of a phase change, water transforming from a liquid state into a gas, all thanks to heat energy. Boiling is a massive, energetic escape of trillions upon trillions of water molecules, each one breaking free from its neighbors in a spectacular display of energy. It's science in action, happening every time you make a cup of tea, cook pasta, or simply watch a pot on the stove. The next time you see boiling water, take a moment to appreciate the invisible drama inside, the constant movement, the energy, and the transformation from liquid to gas. Science is everywhere, even in your kitchen, quietly shaping the world around you with every bubbling pot. Now that you know the science, try this experiment at home. With a grown-up, fill 2 pots with water, add salt to one, leave the other plain, heat both and watch. The plain water boils first. Why? Salt makes it harder for water molecules to escape, raising the boiling point. You've just done real chemistry. Science is about asking questions and trying things out. Your kitchen is your first laboratory. Stay curious. Every question leads to a new discovery. Go try it and see what you find.